No.
Okay, guys, so as a continuous to as we are continuing to revise the previous lessons, today we'll continue with chapter 15, lesson 5. What are some sources of electricity? So before we move on, we already know that electricity is a type of energy, okay? And we can get energy from different resources, from different parts. Um, right? Like we can get electricity from maybe moving water. We can change this moving energy into electricity. But before that, we guys need to know that we need energy everywhere. We get energy from the food, the car gets energy from the gasoline we put in. Yeah, so energy is like everywhere. Even things that are standing still and not moving around still have energy. Do you guys remember what do we call the energy of things that are, in a certain possession or have certain conditions?
Can I answer?
Yes, you can raise your hands for this.
The
You can raise your hands for this. Yes, yes. We have Adito.
Potential energy.
Yes, potential energy. Yes. Well done. Thank you so much, Adito. So potential energy is the energy of an object that does not move but still have energy stored in it. Okay. Okay. Now we have
okay.
two pictures here. We have a roller coaster at the top of a hill. It's not moving yet. It's not supposed to be moving yet. And we have a rubber band being stretched. So, as we mentioned, potential energy is the energy of an object because of its possession or condition. So, the first possession is like the roller coaster here. It's at the top of the hill, it's going to move. So, we know that its possession right now gives it potential energy. Because of the condition of an object, we have a rubber band being stretched. So the condition of the rubber band right now is that it's being stretched. In this case, it's not moving yet, it's storing energy in it. And what type of energy is this? As you guys mentioned, it's potential energy.
Potential.
Yes. So basically, we have potential energy and kinetic energy, but we have different forms for them or different shapes for them. Okay?
Okay.
Yes, you can't always see potential energy because the object is not moving most of the time, so you can't see the potential energy or you can't see evidence for potential energy, but you still know that. For example, the bike standing at the top of the hill here. I'm sorry, it moved. The bike is standing on the top of the hill here. We know that it's not moving, but you guys can't see an evidence that still has energy. But you know that because of its possession, where it is, yani, it's like now having potential energy. The second type is kinetic energy. And kinetic energy is the energy of motion. And this one we see evidence of. Like when you start seeing something moving or rolling down a hill or the roller coaster moving down or the bike here moving down the hill. So you kind of see an evidence that this thing is moving. So yes, now it has energy, but this energy is another type which we call kinetic energy, which is the energy of motion. So we have a very important question. How are potential energy and kinetic energy related together? So they are related because they can't happen without each other. For example, kinetic energy is not going to be there without potential energy, and potential energy is not going to be there because without kinetic energy. So they are kind of related. The bike will stop somehow, right? As the bike moving or an object is moving, it must stop somehow. It's not going to continue moving all the time. So as it stops, it's going to now change all its energy into potential energy. Now, when it starts to move again, it will change all the potential energy into kinetic energy and so on. Okay? We can measure the kinetic energy by how fast or slow this object is. Like the faster the object is moving, the more kinetic energy it has. So that's not it. Like, okay, I can be running so fast. So now I'm having a more kinetic energy. But what if I am running? Guys, if you can see the voice cutting, maybe it's the internet. Yes, so back to what I was saying. So I could be running really
Miss, your
fast.
voice is clear.
Okay, thank you. That's nice. I'm just telling you guys because of the internet connection that if the voice is cutting, it's going to be the internet connection anyway. Okay, so I could be running so
Okay.
fast, but I'm running next to a car. A car is bigger than me, right? Has more mass than me. So which one will have the more kinetic energy يا باسل؟ باسل؟ باسل؟
Yeah. Yes.
You said you wanted
Yes.
to answer a question.
Yes.
Yes, so which one will have more kinetic energy now? Me or the car? We're moving next to each other. I'm running. The car is also moving on. So which one will have more kinetic energy?
Car.
The car, right. Not because it's only the fastest car, it's faster than me, but because also it's bigger than me. It has more mass. It has more mass, okay?
Math.
Yes. Guys, I want to see something before we continue. In the term exam, try to read the questions really carefully. Okay, read the question carefully because some of the question could be repeated, but in a different form. يعني maybe in the worksheet I asked for the bigger or the faster object, but in the term exam I'm asking you for the slowest one. So you have to be careful for that. Okay? So if you saw a picture that you already have in the worksheet, so don't go pick the same answer. Read the question first, understand what's going on, and then pick the answer. Maybe I'm asking you for something else. Yes, someone said miss?
The potential energy and the kinetic energy. You said they are related, right? Because
Yes.
if, like, Miss, I don't understand this part. Like,
What part?
this one. Where is this one?
Which part?
This one.
It doesn't say anything. Yeah, Muhammad. I just said they are related. I mean, nothing or any object will keep on moving, but it will never stop, right?
Yes.
Will you keep on moving till the end? You will stop at some point. So that
Okay.
means all the energy now, or the energy of motion you're having, will change into potential energy because you stopped. But nothing is gonna be standing
Okay.
still without movement for forever. Somehow it's going to move again. So yes, now all the potential energy will change back into kinetic energy. For example, this bicycle here, the one you can see, okay, he's climbing up
Oh,
a
yes,
hill
I
with
see
his
it.
bike, right?
But now I don't. Okay.
I'm sorry, I just had to admit some of your friends. So you can
Yes.
see the bike climbing up the hill. So yeah, at some point he needs kinetic energy. And another point, all this kinetic energy will actually change into potential energy. But will he stay up the hill for the whole time? He must get down, right? He
No.
must change this potential energy into kinetic energy. So that's why it's related. I mean, he can't move up the hill without potential energy and kinetic energy together. That's why they are related. Okay?
Oh, okay. I understand now.
I hope you do. If you don't,
Okay.
it's okay. I can repeat it again. It's okay.
No,
Yes, Mohammed.
I understand now. Thank you.
Okay, you're welcome. Thank you so much.
I
Okay, guys.
understand now.
Okay. So the last thing is that kinetic energy is measured by how fast this thing is, but not only its speed, but also its mass. For example, I'm running along with a car. Which one will have more kinetic energy? As Besson said, it's going to be the car. Why is that? Because the car is bigger than me, so it has more mass, so that will lead it to be way faster. Okay, someone said miss? Yes?
Yes, Miss. The kinetic
I know the kinetic energy. What about the potential energy?
What's going on with it?
Like the meaning of it.
Diane, we already said this at the beginning. What's going on? Guys, didn't you hear me at the beginning? Did you have a problem in hearing me? Potential energy is the stored energy.
Yes.
We can say the potential energy is the stored energy, or we can say it's the energy of an object because of its possession or condition.
Okay.
Okay? So it could be the energy of an object because of its possession or condition, or we can say it's the stored energy. Okay?
Okay.
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 Okay, thank you. So after this, we have two examples. I'm sorry, maybe more than that. We have three examples: the hydroelectric power, the geothermal energy, and last one is solar energy. Those three examples of energies are a great example of both kinetic energy and potential energy working together. For example, in the hydroelectric energy, the moving of the water, or the energy of motion of the water, or the kinetic energy of the water will change into electricity, right? So here we have a mix between potential and kinetic. Where is the potential energy here? When the water is behind the dam, it's not moving yet. In this case, it has potential energy, right?
Yes.
Yes. But when it starts moving down and hitting the turbine, so the turbine will keep on moving on, in this case, all the potential energy of the water change it into kinetic energy.
So
Because the water
energy
started moving downwards. But then this kinetic energy is going to change into electricity because it's going to move all the turbines, and the turbines will actually create electricity. So in hydroelectric power, this is the power, it's a really good example again of potential and kinetic energy, but of the water, falling water. So at the top, the water has potential energy, as we mentioned. And then when it starts moving down, it starts to have kinetic energy. Then all the kinetic energy will change into electricity. People use dams in order to light homes. Dams are really good source of electricity. A huge dam can supply electricity for a big city. A smaller dam can actually supply it to maybe, a farm or a ranch or something like this. Okay, so yes, they do bring a lot of electricity to some places. Okay, now the geothermal energy, and again, the geothermal energy is the energy or the heat that comes from the inside of the earth. We know that under the earth's surface, there are a lot of energies there, heat because of the magma and everything hot down there, right? So the heat from inside the earth can be used. Okay, we call this the geothermal energy. We also use it to produce electricity. The heat, the steam from the hot water coming from down the earth, this steam, the water vapor, will cause turbines to also move, and these turbines will then create electricity. Okay, but this part you guys are not asked to learn. Yeah, how the technique works, you can just only read it. I'm not going to ask you for it in the term exam. Okay? Okay, everyone?
Okay.
Yes. All I need you to know is that geothermal energy is the heat that comes from the inside of the earth, and it's used to produce electricity. That's it. Okay, I don't need all the technique. The last one is solar energy, and we know solar actually means sun. Do you guys know that? In old language, they used to call the sun sola and the moon
Yes, we
luna.
know.
That's why we have solar energy. We call it solar. So solar energy is the energy from the sun, and we use this energy from the sun and we turn it into electricity too. But we don't actually get one shape or one form of energy from the sun. We get two. We get heat and light. Both of them are really important energies. Without the sun in the morning, we can't see anything, right? It's total darkness, right?
Yeah.
Yes.
Yeah.
Some people now use solar panels, those solar panels here. This solar panels, absorbs the sun's energy and store it and then change it into electricity. So solar energy can heat buildings. We can use it to heat the building, or we can use it to heat water. Maybe we need some hot water. Some people use it to produce electricity too. Okay. You can see these solar panels in different devices, like in calculators, for example. There are some type of calculator that doesn't work, and it doesn't have a switch to turn it on and off. It kind of switch on and switch off by itself. Do you guys know this calculator? Like, it doesn't have an off switch. It's actually using solar panels. Yes.
Miss Noha,
Yes.
I have one that works with light, but it is not working.
Yes, it's not. Maybe it needs, I don't know, maybe it's not actually a real solar panels, and maybe it needs batteries, or something is broken in it. Okay, guys, so that was lesson 3, as we mentioned. Thank you so much. Was it Dream here?
Miss Noha,
Yes.
can you get the solar energy again, because I want to say something?
Yes.
It's so easy.
The solar energy, the sun is like the sun is not doing something. So this is a potential energy. When it gives sun heat to the solar panels. So this is kinetic energy. Then
Well,
completes,
actually,
it
it's when the charges starts to move inside the wires. This is kinetic energy.
yes. The energy starts moving the wire. So this is kinetic. The kinetic change to electricity. So when it finished the kinetic energy, it changes to electricity, because to load more electricity, right?
Well, it's not like it's going to change. Electricity is not going to change. Like, but we need solar energy because it's a clean energy. Clean energy means that doesn't cause pollution, and it's a lot of energy. I mean, sun rises every day, alhamdulillah, and we have enough energy from it. So all it happens is that these solar panels, Yalayan, stores the sun's energy, the solar energy. And then there is in some technique, somehow, I'm not really aware of this, but somehow these solar panels will change all this stored energy. The stored energy here is the potential one. Then it will change all the stored energy into electricity, or maybe, yes, or something else we can use in heaters, for example. But also heaters need electricity. So yes, in this case, it's kinetic energy now. Okay.
Well, so it changed from potential to kinetic, and then kinetic to electricity.
Yes, but all I want you to know is that it's solar energy, and now we use solar energy to produce electricity. That's it. Okay?
Okay.
Thank you so much, Leia. Okay, guys, now I will take people randomly, so you don't have to raise your hands. Hamza, you're raising your hand. Do you need something?
No, I forgot to do it.
Okay, Muhammad, the same thing. Are you raising your hand, or do you need something?
Same as Hamza.
Okay. So guys, you can lower your hands now, so I will have your names in a random way. So we'll start with Muhammad. I'm sorry, Malak. Malak, number 1.
Yes.
Malak, yes. This energy is because of the motion or due to motion. Is it called kinetic or potential energy?
What?
Number 1, sweetie. Can you see the question number 1?
Yeah, this energy due to motion.
The energy because of the motion, the moving objects. What do we call this energy? Potential or kinetic? Yes, Malak. It's really simple question. You know the answer.
Yes, this energy due to motion.
Yes, it's going to be kinetic energy. Thank you, Malak. Okay, now Abdurrahman. Abdurrahman Karim. Abdurrahman Karim. Do we have Abdul Rahman Karim?
Yes.
Yes.
Yes, I'm here.
Which of these has the most potential energy? A, B, C, or D?
C.
C, yes, has the most potential energy because it's the car now standing up there. Okay, a question like this. Thank you so much, Abdurrahman. A question like this, guys, I can bring the same picture and I'm not going to ask you for the most. I'm going to ask you for the least kinetic potential energy. So in this case, the least potential energy will be the man or A. So guys, be careful. That's why I'm telling you to read questions carefully, please. Okay? Because maybe I'm not asking you for the
Okay.
same thing. Okay? Thank you, Abdul Rahman. So it's going to be C. Number 3, we have Aditu.
What is potential energy? The stored energy of an object
Yes,
due
it's the
to its
stored
position
energy
or
of an object
condition.
because of its position or condition. Thank you so much, Aditu. Now we have Basil. Basil is next. Basil.
Yes.
Yes, number 4. I'm sorry, the
Okay,
picture
miss.
moved. The picture moved away. I'm sorry for that. So it says, which passenger has the most potential energy? A, B, C, or D?
D.
D, yes, because it's the higher one. Yes. Number 5, we have Iyad Adil.
Miss Noha.
Iyad Adil. Yes, someone said
Yes,
Miss
miss.
Noha. Yes.
Is it going to the left or right?
Well, they are getting up. Who's going to the left or right?
Oh,
What
okay.
is this question? It's like he's showing you different passengers on different positions or different heights. And he's asking you. It's not like, I don't know, it's like if they're moving, I think they're moving to the right, I think. Yeah, they're getting up the hill, not because they are facing to the right. So I think they are moving to the right too. Yeah, they are trying to climb the hill. Okay. Okay, now we have who said who did I
Okay,
say?
that's how it does has most potential energy.
Well, it's not moving now. He's giving you a picture of people standing still. Yeah, this object is not moving right now. They're standing
Oh,
still.
standing still.
Okay, yes. Okay, now we have who's next?
Okay.
Can I answer?
Guys, I'm picking you randomly. So try to not mute yourselves or raise your hands because this will change your order in the list. Okay, because I'm using the participants list. Did I say who's next?
Yeah.
Yes, yeah. Okay, number 5, it says, as the sky driver fall, the sky, I'm sorry, divers fall, the what energy is changed into what energy? He's falling from a plane. So what do you think? Huh?
I can يعني choose a black.
You what?
There is something that this.
Something blocking the screen?
Yes.
Yes, it's
Yes.
the participants list, but I read the question for you. So
Okay.
you already know it. You don't need to see the whole question, huh? Let me change it for you. Can you see it? Huh?
Yes. Yes. This.
So the skydivers, do you know the skydivers, people that jump with parachutes in? Yes. So now he was on the plane and then he
Yes.
jumped downwards. So what kind of energy is changing into what? Huh?
B.
B, yes, it's gonna be potential into kinetic because he was standing still on the top of the plane, but then he jumped, so all his potential energy will change into kinetic energy. Thank you so much,
Yes.
Iyad Adil. Now we have, who's next? After Iyad, we have Farah. Farah?
Yes.
Yes, Farah. Number 6. Look at the picture below. At which point will the roller coaster have the greatest amount of potential energy?
A.
Yes. has the greatest potential amount of potential energy is gonna be A, yes, the highest point. So against question like this, I could ask you for the opposite thing, the lowest. So it's gonna be B, not A. So that's why read questions really carefully. Okay, guys. Okay, so it's gonna be as she said A. Now number 7, we have I'm sure the participants let's disappear. Okay, after Farah we have Hamza. Hamza.
Hello,
Yes, hello
number
Hamza.
7.
Yes, number 7.
Okay. A student rolls these 4 items on the same surface and at the same speed. Which item will have the greatest kinetic energy? Not the beat ball.
It's gonna be the biggest one, which is
The biggest one.
uh-huh.
The marble is the smallest. The table
Yes.
tennis also is small.
Yes.
I
Now
think the beach ball.
beach ball and basketball. Now be careful. Who's heavier?
Oh, heavier?
Yes. I think it's the
Um,
basketball, right?
Yes, but
Yes. You can answer number
I
8.
I never thrown a basketball, so I don't know
Really? It's
how it
so
feels.
heavy. It's heavier, yani.
It's very
I
I
shot it
think
with
it's
my
just
leg
like
once.
the football, but a little bit heavier, I think. Well, it's okay, it's gonna be basketball. So marble, as Hamza said, is the smallest one. So it's gonna be the one that has the lowest kinetic energy. So be careful for this. Now, number 8, potential energy. يا Hamza برضو. Potential energy is sometimes called Hamza. We can't hear you, by the way.
My mic muted.
Okay.
Like not the mic I'm
It's
wearing
okay.
right now.
Number 8 is gonna be
Sword.
sword. Yes, thank you, Hamza. Thank you so much.
Moving is for kinetic.
Yes, moving is for kinetic. Well done. Okay, now we have Iyad Tamer, number 8.
Potential energy is sometimes called.
No, it's number 9. I'm sorry. We did number 8. I'm so sorry for that. Number 9, yeah, Iyad, معلش.
What type of energy is in this picture? Miss, I
Yes.
cannot see the picture from yeah.
Okay, I
Thank
took it off. Huh. So here he's stretching like something like a rubber band. He's stretching
Yes.
it. It's not
It's
moving.
potential.
Yes, it's gonna be potential. Thank you so much, Iyad. Thank you so much. Okay, now we have who's next? We have Joyda. We have Joyda, Jana, and Jumana. So you guys know the order. So Joyda here, number 10. What are the 2 main differences between potential and kinetic energy? Can you tell me the answer?
Okay. The static energy.
Static?
Yeah. I remember it, but I cannot say it.
Just use your own words. You don't have to use the same answer. What is the difference between potential energy and kinetic energy? You can say, what is potential energy and what is kinetic energy?
Okay.
For example, what is kinetic energy? It's the energy of what?
Energy.
Huh? Joyda, use your own words.
Okay. The static energy that we it's used by circuits and wires.
What circuits? Yeah, Joyda, we're not talking about electricity here. Focus. We talk about potential and kinetic energy. Have you been here since the beginning of the session?
Yes.
Yes, we said that potential energy and kinetic energy are 2 types of energies that we can change into electricity at the end. But first, what is potential and what is kinetic? Potential energy is the energy that is stored in the object. Like it's not moving yet, but still has energy in it. But kinetic energy is the energy of motion.
Yes.
Jaida, do you know that, or what's going on? Or you just
I,
confused? I don't know.
I know, but I confused.
Okay, but Jaida, just make sure you use your own words. You don't have to use the same words and the same answer I put in the model answer. Okay.
Okay.
Thank you, Jaida. Now we have Jana. Jana is not here anymore. Jana? Jana? Okay. Jumana then? Jumana?
Yes.
Yes, Jumana. Can you say what is hydroelectric power?
Hydroelectric power is like
Yes.
Where
does it come
like
from?
electricity.
Well, it produces electricity. Yes. But what is hydroelectric power? Like, is it moving balls or moving bikes or falling water? What is it?
I can't remember.
You can't remember hydroelectric power?
Miss, I know.
I'm trying to remember.
Okay, guys, you need to focus more during the sessions, please. And try to read the lesson before the sessions. Okay, hydroelectric power is the power that we get from the falling water. We use the falling water to get energy, which is electricity in this case. So kinetic, we can say hydroelectric power is the power of falling water that we change into electricity. The geothermal energy, which is the second type, is the energy or the heat that comes from the inside of the earth.
Okay.
Okay.
Okay, thank you.
Now I will have to move on. Guys, please try to study harder. Can you tell me what is solar power, ya Jumana? Jumana, can you tell me what is solar power? Solar? Where does it come from? Jumana, can you still hear us?
Miss, can I answer?
No, guys, give her time. Okay.
Okay, sure.
Jumana can't hear us. I don't know. Okay, so we have Reem. I'm sorry, no, it's Bilar. Bilar is next. Bilar, can you tell me what's solar power? Bilar, what is solar power? It's the power from the sun, guys. What's going on? Everyone.
I can hear you.
Yes, I know. I keep calling your name. Okay, now we have Reem and then Rugmini. Reem and Rugmini. Guys, can you answer this question? It's matching. Reem and Rugmini, okay? We'll do this question. We'll continue this revision sheet next time because we only have 1 minute. So a material that lets, yeah, Reem first. Reem is first. A material that lets electricity travel through it easily.
Conductor.
Conductors. Thank you, Reem. Rugmini? Rugmini.
Yes.
An electric charge that builds up in an object.
That builds upon an object.
Builds up on an object.
Electricity.
Yes?
Static electricity.
Static electricity. Thank you so much, Rugmini. Okay, guys, so for next time, we'll do this revision sheet, which is tomorrow. Make sure, please, that you study these 3 lessons really carefully. Chapter 15, lesson 1, 2, and 3. Guys, make sure you study them really well. So tomorrow, when we do the revision sheets, you will understand everything. And if you still have questions, because we only have this week. So be careful for that. Okay, everyone?
Okay.
Yes, thank you, everyone, for today's session. See you, inshallah, tomorrow. Okay?
You're welcome.
Bye.
You're welcome.
Bye.
Bye.